Welcome back to Summarize Science. Imagine controlling a robotic arm just by thinking about it. This technology could be life-changing for people with limited mobility. But what happens if the robot misinterprets your thoughts? That's a huge safety risk, and it's the exact problem this paper tackles. Researchers from the University of Oxford have developed a framework called Guardian, which stands for Gated Uncertainty-Aware Runtime Dual Invariance. Think of it as a super smart safety filter that sits between your brain signals and the robot's actions. Its main job is to prevent the robot from doing something you didn't intend, especially if the brain signal reading is fuzzy or weak. So, how does it work? Guardian performs two different kinds of safety checks in real time. First, as shown in this diagram, it checks the physiological invariants, which relate to the quality of the brain signal itself. It looks for things like high uncertainty, signal noise from muscle artifacts, or if your intended command is flipping back and forth too quickly. If the signal quality is poor, it simply tells the robot to halt and wait for a clearer instruction. The second stage is a logical check. After confirming the brain signal is trustworthy, Guardian checks if the intended command makes sense in the real world. For example, it uses planning logic like you see here to ensure the robot doesn't try to grasp an object that isn't reachable or move through a wall. Only if both the physiological and logical checks pass does the robot execute the command. Now here's the most impressive part. The researchers tested Guardian with brain signal decoders that were not very accurate on their own, sometimes only getting it right about 27% to 46% of the time. Despite this, as you can see in this table, the complete Guardian system achieved a safety rate of 94 to 97%. It correctly intervened to stop a wrong action or correctly allowed a right action almost all of the time. They even tested its robustness by digitally adding noise to the brain signals to mimic a challenging, real-world environment. The system proved to be highly robust, correctly increasing its interventions as the signal quality got worse to maintain a high safety rate. This demonstrates the desired conservative behavior for a system designed to help users safely. So to recap, the Guardian framework acts as an interpretable safety layer for mind-controlled robots. It uses both physiological and logical checks to ensure the robot's actions align with the user's true intent. The key takeaway is that it can provide a very high level of safety even when the technology for reading brain signals isn't perfect. This is a massive step forward for making brain-computer interfaces trustworthy for real-world applications, from assistive robotics to advanced neuroprosthetics. It helps build a critical bridge of trust between human intent and robot action. What do you think about a future with mind-controlled assistants? Let us know in the comments below. Thanks for watching Summarize Science, and don't forget to like and subscribe for more.